Hi friends, today topic is vectors. I have one example that what is the volume of this cube? The volume of this cube is 10 cubic centimeters. My doubt is in which direction the volume of this cube is 10 cubic centimeters. That is in any direction the volume of the cube is 10 cubic centimeters only. So there is no direction for the volume. This 10 cubic centimeters indicates the magnitude of the quantity and there is no question of direction for the volume. Another example is what is the time now? The time is 5 p.m. My doubt is in which direction the time is 5 p.m. There is no direction for the time is in any direction. The time is 5 p.m. only. Another example is what is your weight? Let's say my weight is 60 kgs. In which direction the weight is 60 kgs? Yes, this question is valid. The weight has the direction. It is always in normal to the ground because weight is equal to mass into acceleration due to gravity. Acceleration due to gravity has a direction that is normal to the ground, that is in downward direction. Take a look at magnetic field and the electric field. The direction and magnitude of the electric field is the direction of the electric field is always from positive plate to negative plate. Let the magnitude of the electric field is 5 Newton per coulomb and the direction is in from positive plate to negative plate. In case of magnetic field, the direction from the north pole to south pole. From the above examples, we can conclude that some of quantities are having magnitude plus direction and some of the quantities are having magnitude only. Let name it as vector for things which are having both magnitude and direction. Let name it as a scalar for things which are having magnitude only. That means a vector is having magnitude plus direction, scalar having only magnitude. Examples of vectors. Examples of vectors are displacement, velocity, acceleration, force, weight, acceleration due to gravity, gravitational field strength, electric field, magnetic field, dipole moment, torque, linear moment, angular moment. And examples of scalar are mass, volume, distance, speed, density, work, power, energy, and so on. I have doubt that even though distance and displacement having same units, why one is a vector and another is a scalar. Let me tell one example that I traveled 4 kilometers towards east and now I turn to north and travel 2 kilometers and I turn to west, that is 2 kilometers. What is my total journey? That is 8 kilometers. In which direction I traveled? The total journey is 8 kilometers, but there is no proper one direction. My journey individually having directions, but entire journey has no particular direction. So I traveled 8 kilometers magnitude only. There is no direction for my traveling. So it can be called as a scalar, that is a distance. My friend traveled from O to P in shortest direction, that is northeast direction, that is from P to O. The magnitude of P to O is root over 2 square plus 2 square, that is 2 into root 2. That is the magnitude, and the particular direction, that is northeast direction. So it can be called as vector, and direction is a northeast direction. So we can call this traveling as a displacement. In same way, speed always changing directions. There is no proper one direction for the speed. So it is a scalar quantity. But velocity is a vector. It has particularly one direction. Here, one example is we are all using speedometer per vehicles because all vehicles continuously changing directions. There is no particular direction for the vehicle, so we are using speedometers. In some cases, mm, there is no change of the direction. In that cases, we are using velocity meters. Now, my doubt is electric current is a scalar or vector. Even though current has the direction, that is not a physical direction, which is the direction which is with respect to voltage. Current obeys algebraic sum but not vector addition. So current is a scalar. That current I is at an angle of 30 degrees indicates the indicates that 30 degrees indicates angle between voltage and current, no, but not with the x-axis or y-axis. Product of two vectors. Chances of product of two vectors may be a vector, may be a scalar. There is no third chance for product of two vectors. If the result of product of vectors is a vector, that is called cross product. If the result of product of the vectors is a scalar, that is called dot product. Let me tell an example. By applying force on a wrench in y direction, y bolt is moving in z direction. Here the torque is the product of radius and force. Observe radius and force are vectors, and the resultant torque is also a vector which which is out of the plane. The direction of the torque is out of the plane of R radius vector and force vector. Here product of two vectors gives the vector. So such type of products we are using cross products, and this type of product is called cross product. Here R cross F is equal to torque, which is out of the plane of radius vector and force vector. Another example for cross product is EMF is product of magnetic field and length of the conductor. When magnetic field in x direction, conductor moving in y direction, produced EMF is in z direction. That is not in magnetic field direction, not in moving of the conductor direction, but it is in z direction. That is Let C is equal to A cross B, then C is equal to mod A mod B sin theta, and the direction of the C is in normal to the AB plane. Here E is equal to BLV sin theta. One observation from this cross product is where sin theta present, there is a chance of cross product. Cross product gives area enclosed by those vectors, which is magnitude of the resultant vector is normal to the dot product. When the product of two vectors are a scalar, then we use dot product. Here, the projection of B on A vector and the multiplication of that projection and A vector can give the dot product of AB. A dot B equal to AB cos theta. Here, one real-time example for the dot product is when applying the force on the block in the direction of theta from the horizontal, then it displayed by delta dx. Then what is the work done? The work done is F dot S, that is work done is equal to Fs cos theta.